where we learn how to use arrays. Okay, so using arrays is our topic today. Now, why do we need to use arrays? Like I said earlier, if you have multiple data and you need to have all of them stored in the memory, sometimes you don't have to have all of them stored. If you need to have all of them stored, then array is the only way. And also, if you store them in array, then you can use loops to manipulate them. One loop can do everything you need to do with the array. Even if the array is of size 500, one loop of 2 lines or 3 lines will take care of the manipulation. So we're going to see how to use the loop to manipulate the arrays. Let's proceed to do first example. I'm starting out with simple examples. Write statements to declare an array of size 20 and then initialize the elements with numbers 1, 2, 3, 4 all the way to 20. So I want to store these numbers 1 through 20 in an array of size 20. So the first element of the array should have 1, second element should have 2, and so on. All right, to do that, I declare the array. This is your declaration. It says num will be an array of size 20. So 20 memory cells will be allocated. Usually 20 sequential memory cells will be allocated. And the I is subscript variable. You always need a subscript variable that will be integer type to represent the subscript. Subscript is what we put in the bracket. So here is how you store the numbers 1 through 20. For I going from 0 to 20, less than 20, as you can see, so that I will go up to 19. If you remember, if the array is of size 20, let me write on the board, if the array is of size 20, then the very first element of the array is going to have num 0. Num 0 is the name of this. And the second element of the array has name num 1. And the last element, the 20th element, has name num 19. So you need to make sure the subscript value, that's what I represents. I should go from 0 to 19. That's the range if the size of the array is 20. So that's why my loop says for I going from 0 to less than 20, which means 19, I plus plus. For all those i's, num I equal to I plus 1. See, when I is 0, I plus 1 is 1, and num 0 is getting 1. So this will assign 1 to num 0. So we have a 1 in the num 0 now. And then I becomes 1 now. I was 0 before. I increases to 1 here. When I increases to 1, I'm doing num 1 equal to 1 plus 1, which is 2. So num 1 is getting a 2. So you have a 2 here. And the next element, num 3, I becomes 2 now. When I is 2, I less than 20 is still true. So num 2 is getting 2 plus 1, 3. So you have a 3 going in here. And it keeps going. And num 19, last entry, will get 19 plus 1, 20. 20 goes here. So when this loop finishes, your array has those numbers, 1, 2, 3, all the way to 20. Okay, next problem is an array is declared as float val 100. It has numbers already stored in it. So according to the problem, the array already has numbers. So what you need to do is write statements to replace each entry with the square of the original value. To replace each one with the square, I can say for I going from 0 to 100. As you can see, you always need a loop to manipulate the whole array. And I goes from 0 to less than 100. Val I times val I is the square of the val I, and that goes back in val I. So that replaces the original value with, let's say this is the array I'm using. If I use this array and that program that replaces every element with square of the original value, then when the I is 0, val 0 times val 0 is going into val 0. The val 0 is 1. 1 times 1 goes back into val 0. So that's 1. Then when I is equal to 1, num1 is going to be replaced with num1 times num2. Num1 is 2. So num1 times num1 is 2 times 2, 4 goes in here. When the subscript value I is equal to 2, num2 is getting replaced with num2 times num2. Num2 is 3, so 3 is replaced with 3 times 3, which is 9. So that 9. So every element is replaced with the square of the original value. Now then, example 3 says, an array declared as char val 100 has characters stored in it. Write statements to count how many punctuation characters are found. So to do all that, to go through the entire array of size 100, one loop will do it. For I going from 0 to less than 100, I plus plus, if val I equal to period or comma or semicolon, and so on. If it is equal to any one of these, the list is longer than this, but it's okay to just write a few. If it is equal to any one of those, count increases. I just need to count how many punctuation characters are there. And when the loop ends, the counting is done. So this loop takes care of all of the 100 elements, and it'll count all the punctuation characters. When that finishes, I need to see out the count. Okay, moving on to next application example. Write a program to store the grades of students, which are these. The grades are given to you. You need to store these grades and then count how many students get A, how many get B, and so on. I have the grades already, so I don't need to get them from user. I can assign them directly to the array. So declare the array and assign the grades right there. So array size 15 and 15 grades are stored. Then I need always a subscript variable. Remember, whenever you're using array, you're going to need this I. We normally use I, J, K for subscript. And then A count is counting number of A's, B count is counting number of B's, and so on. Set them all to 0. Now, all you need is a loop to manipulate the entire array. I going from 0 to 15. Each grade I is compared against 90, and if it is over 90, A count increases. Else if, you need else if, otherwise it'll be wrong. If the else is not there, then grade I over 80 includes anything over 90, right? So if the grade is 95, you're going to end up increasing B count if you don't have the else if. So that's why this has to be done as else if. If a grade is over 90, then that A count goes up. Else, that means not over 90. Then if it is over 80, that's when its B count increases. Else if it is over 70, C count increases, and so on. If none of these are true, none of these conditions are true, that's when it's a failing grade. So that's why the else says else F count, because else will be executed only if none of the above are true. So that will count all the A's and B's and C's. And next thing we need to do is write those counts. So cout statement will write the counts, and that'll be it. If you have any question, feel free to interrupt and ask the question. All right, example 5. Write a program to obtain 30 floating point numbers, which are going to be daily sales, and store them in an array. So we know there will be 30 numbers, but we are going to have to get them from user. So this time we cannot assign, we assign the values here because we knew the data. And we cannot do that in this problem because we don't know the data. So it has to come from user, but we know there will be 30. So our array can be of size 30, and tot sale is where the total will be stored, some of the values. Average is where the average will be stored. Now to get all the data, I need a loop. For I going from 0 to 30, I plus plus. 0 to less than 30. So it'll go up to 29. It'll keep asking for data over and over. And when I is 0, When the user enters the data, it's going into cell 0. Then I becomes 1. I just increased here. And as long as I is less than 30, it'll ask for a test, asks for a cell number. Now it goes into cell 1. The I is changing. Then I becomes 2 and asks for another cell number. It goes into cell 2. So the entire array is getting filled up with their numbers when this loop finishes. When the loop finishes, all the elements 0 through 29 are having values. Now go on to process. What is the processing I need to do? I need to add them up. So start another loop for I going from 0 to 30. Tot cell equal to tot cell plus cell I. So when I is 0, I'm adding cell 0 to tot cell, putting it back in tot cell. Then when I becomes 1, I changes here. So I becomes 1. Cell 1 is added to tot cell. Result goes into tot cell. And it keeps going. When I is 29, I add cell 29 to the tot cell. And that's when it's finished. So when the loop finishes adding up, it'll come down here, average. Only when the loop is finished, I need to do this. Only then the tot cell is finished. The tot cell is already done, adding up all the numbers. So I'm dividing that by 30 to get the average and print the average. That's all there is. Okay, question. Instead of 2 loops, can I do it all in 1 loop? Anybody? Is there any way I can combine these 2 loops into 1? No answer? Actually, I can. I can put this statement in the other loop. So let me make room. And if I move this over there, let's check it out. Okay, when I is 0, I'm asking for the cell, and it goes into cell 0, and that cell 0 is added to tot cell, and it goes up back to the top and increases I to 1. 1 less than 30 is true, so ask for another cell, and that will be stored in cell 1, and now cell 1 is added to tot cell, and it keeps going. After getting each number stored in the array, immediately after that, I'm adding that number to the tot cell. Nothing wrong with that. You can do that. If you do that, then you're only using 1 loop to do all of the work. And the next statement you need is the CR statement. So you don't need the other loop. So the second 2 loops is not really necessary, but I did that so that you can understand better. You can just use 1 loop to get all the data from user. And that loop goes 30 times because you know exactly 30 numbers are going to come in. Only if you know exact number of data, then you can do this. If you don't know the number of data coming in, then we have to do that differently, and that we will be discussing in the next class. So the examples we are doing here, in these examples, we know the count. All right, so another problem, this one says, write a program that obtains 40 integers from the user, stores them in the array, and then computes average and maximum. 2 things to calculate, average and maximum. All right, so array is going to be num40. Sum is going to hold sum of the grades, and it's initially 0. And average is going to hold the average. For I going from 0 to 40, you need a loop for doing anything with the array. C out into the number, C in num I, and that will get all of the data. So this loop is getting all the data. And after that, I need another loop to add up. I could have done this in the first loop if I wanted to. I'm adding all of the numbers and dividing the sum by 40 and storing an average. Now to find the maximum, the same technique we learned before. We used it for smaller collection of numbers before. Now we are using it for large number of data. The idea is the same. You start with max equal to first number. First number in the array is stored in max. And then I starts at 1 because num0 is already stored in max. I don't need to compare that against the same thing, same number. So I starting at 1 to go up to less than 40. Each number, num_i, is compared against max. If it is bigger than max, copy it into max. If it is not bigger, it will be ignored. And that's all the loop. This loop finds the maximum because any number, if any number in the array is bigger than the current max, that number is copied into max. If you go through the entire array with that idea, then when that loop finishes, max has the largest of the entire array. Now we already understood how it works, so you probably understand it. I don't need to go over with an example. I did that before, going over it with a set of numbers. If anybody wants, I can go over again. And when that loop finishes, I can see out the average and see out the maximum. Now, could I have done all these in one loop? Yes, I could have. How do I do that? I throw this, I can copy that and put it in here. I could, okay, I can, if I do it here, then nothing wrong, right? Immediately after storing the data in the array, I'm adding that data to the sum. Nothing wrong with that. Can I find the max also? Okay, let me go to that line, and then I need this, right? If any number is bigger than max, max equal to num_i. So if I can copy that and put it there. Let's see. Okay. There is one problem in doing this. Anybody recognize the problem? When I say the I goes from 0 to 39, when I say num_i greater than max, the num_i is, when I is 0, num_i is num0, but max has no value, right? Max has to have some value. So should I say up here, max equal to num0? Should I do that?
I think that would work.
Okay. No, this exact statement that I have written here is wrong. It's not going to work. Why? What is num0? Num0 doesn't have a value. Only in this loop, I'm getting a value for num0. When I is 0, I'm asking user to enter a number, and that goes into num0. Then I'm adding num0 to sum. That's correct. And comparing num0 to max. To do that, max must have a value. But if I go up here and introduce num0 as max, that's not going to work. Num0 doesn't have a value at this point, right? Only after the loop begins, num0 will be getting a value. Agree with me? So what should I do? Anyone has an answer?
Move max equal to num0 after the cout statement in the loop.
After the cout, statement in the loop,
The CN statement in the loop.
the right here, you're saying, okay, right here, go back to the previous line, and you're saying max equal to 0.
Yeah, max equal to num0.
Num0? Oh,
Yeah.
okay. All right, num0, yeah. All right, let's look at that possibility. And okay, let's say we do that. Now, clearly this statement is not going to be right. At that point, we don't have num0. But let me leave it there for now and analyze the possibility of this working. After getting, when the I is 0, num0 is received, stored in the array, and then max becomes num0. Okay. And then here num0 is being compared against max. The max has num0, so num0 is not bigger, so nothing will be done. Okay. And then I becomes 1. Now that's where we're going to pay attention. When I is 1, I'm getting num1. And I should be comparing num1 to max next. But the max is getting reset to num0 again. And then I'm comparing num(i), which is num1. I is right now 1. The num1 is the next number. Comparing to max. And if num1 is bigger than max, then num1 is copied. Otherwise, num1 is ignored. Either way, I becomes 2 now, and I'm getting num2 from the user, and num2 is being compared to max. Okay, it's working, it's fine. Only thing is, why do I want to re-execute max equal to num0 over and over? By putting it in the loop, I'm executing over and over. The problem is this. Let me work with some numbers, then you will see the problem. Let's say the numbers stored in the array are, first number is, say first number stored is 5, and then 9 and 15, and then 3. I'm just making up some numbers. If I start with that, the max is supposed to find the maximum, right? So let's say max is this memory. Max is this memory. And max is equal to num0. Num0 is 5, so 5 is going in here. Okay, that's fine so far. And then num1, next time through the loop, num1, which is 9, is compared to max. Num1 is bigger than max, so num1 is copied into max. So max is getting the 9. The 9 is bigger, so 9 is going into max. All right, now I becomes, let's go to I becoming 2. When I becomes 0, 1, 2. Yeah, I becoming 2, num2 is getting 15, the value 15. See what I'm doing? I'm resetting max to num0. What does that mean? My max was 9, and now I'm resetting that to 5. I'm going back to 5. And then comparing 15 to 5, not to 9. Okay, understand why that is wrong? If that 9 was 29 instead, that is the maximum. 29 was the maximum, and I had it in there. Now I'm changing it back to 5. So I'm now comparing 15 to 5, not to 29. Okay, so you keep resetting the max to num0 over and over, then you're not going to get to the max. You're erasing any larger number and putting back the first number into it. Understand? That's wrong. So the max is getting reset to the first number every time, and that is not going to work. So setting the max to any value should be done up here, but I cannot use num0 because num0 doesn't have a value. So can I use 0? Then if any number is bigger than 0, that'll be copied into max. Okay, so if you know all the numbers that you're getting are greater than 0, then max equal to 0 can work. In the last project, 4.5.1, you were allowed to do that to simplify matters, but let me explain why that is wrong. We don't know when we write the program, we don't know how big or how small the data are. So if I start my max at 0 and then say if any number is bigger than max, then copy that, all the numbers in the array can be less than 0. If all of them are less than 0, you're going to come up with 0 as your max, but which is wrong. So if all the numbers are negative, then there is the largest number among the negative numbers. That's what we need to find. You're not finding it. So you are not supposed to begin with any fixed number like this. In that particular assignment, it was allowed to simplify matters to make it less complicated for you, but you cannot do that in actual programs. So remember that. So if there is a test question asking you about finding max, you should always start with the very first number stored in the data. The very first number that you have, in this case 5, that's where you should begin. Then you're not, then you are working with all the actual data. You're not working with any outside data. That's the right way. So this, even though in this case, this may work, it would be a bad idea. So therefore, this adding business can be done in here, but the finding maximum really should be done separately like this. For like this loop, max equal to num 0 before the loop begins, and then inside the loop, compare max to every number in the array. That is the right way. All right, moving on. That finishes that section, and you need to do the assignment problems. It's already, the link is already up there. We are moving on to the next section, which is passing arrays to functions. So we just saw how to work with arrays. Now we also have to work with functions that can manipulate arrays. So functions and arrays. That's very common. Using function to work with arrays is a very common practice, and so we need to understand all about it. There are so many things to understand here. So let's say I want to write a function add up that'll add up all the numbers found in an array. So here is a statement, num4 is getting these 4 numbers. And after that, if I want to add up those numbers, I want to be able to call a function called add up and pass this array. So I call add up and pass num. Now, when you pass array to a function, you only pass the name. If you put anything in next to it with a bracket, if I put a bracket right there and write a number, that means what? If I write a number next to the name, that refers to one element of the array. Then you are only trying to pass one element of the array, which is wrong. And also, num4 doesn't have a value. Why? Anybody?
It only goes to 3.
It only goes up to 3. The subscript goes from 0 to 3. So num0 has a value, num1 has a value, num2, num3 have a value, num4 doesn't have a value. So there's nothing there. You'll get error message from the compiler if you write that. So no bracket, just the name is all you need. And I'll explain how that works in a few minutes. At the receiving end, the function add up would have header like this. The very first line of the function will say int add up, and then in parentheses, to receive the num, I need a name, right? To receive the num, I need a name. The name needs to be a name of an array. So this is how you say that, int arr with the bracket. The bracket makes it array. If you don't have the bracket, it'll be a variable. We cannot receive an array in a variable. So you need to receive array in an array. And so the name you make up here should have bracket next to it. Okay, so let's go to understanding passing by reference. Now we learned in the last class how passing by reference works, right? Let me put an example up on the board. Function, let's say function called fun receives two things in parameter, or one thing, let's say, int and x. If I do that, and in the main program, in somewhere in the main program, I have int m equal to 5. And if I call function fun and pass 5, m that is, then if I receive it in a reference, we went over this in the last class. In the main program, m was assigned a 5, so m has a 5. If you pass it into an x, then if x is declared as reference and x, then that x becomes another name for the m. And this function now accesses the original. So if you refer to x here and do x equal to x times 2, something like that, then you are accessing the original value, original memory cell that was represented by m in the memory, in the original program main. That was 5, and you're multiplying 5 by 2 and putting back in x. So you're changing the x to 10. So you have changed this to 10. And when you come back here, after this function call, if you do a cout m, what is printed? What is going to be printed?
10.
10, because the function can now change. Function is allowed to change the original memory. You give access to the function when you do this reference method, passing by reference method. Okay, when you pass an array to a function, you are passing by reference. Whether you like it or not, that's how it is designed. You are not sending a copy, you are giving access to the original memory cell. That's what you're doing. Okay, so why did they do that? Why can't they let us pass by value, pass a copy of the array? The reason is this: when you normally write a program, a real life program, the array you use is very large, like has 500 elements, 1,000, or even 10,000 elements. The data we process normally in real life programming are very large. And so when you're allowed to send a copy of the array, you are making another copy of 10,000 elements. That's a lot of memory you're using. And that's a very bad idea, because you're using up too much of memory, and a program may fail because of lack of memory. So that is very inefficient, and that's why that's not allowed at all. You only allow the function to access the original data and manipulate it. And if you don't want the original data to be changed, then you make sure the function doesn't change them, just use them. And if you want to change the function or change the original array, you are able to do that also. And so it's entirely up to the programmer to decide how he or she wants to handle it. If you don't want the numbers to be changed in the original array, then you can write the function that way. So it's up to you to figure out exactly how you want to do it. But function will be passed by reference. So let me go ahead to the next example. Write a function add up. So I will explain exactly how the passing by reference is going to work. Write a function add up to receive an array and add up the values, and then write a main program that will use this function to add up the numbers 12, 9, 5, and 7. So we have a small collection of numbers just for practice. Now, let me explain. When you pass an array to a function, you are passing only the name of the array. So name of the array will only be received in another name. And so how many elements are there in the array is not passed when you pass the name. You're only passing the information as to where it is. So let me go to the function add up and then explain what happens exactly. You have to pass the size of the array separately because the size of the array is not going to be known in the function unless you pass that. So here's my function. Let's go through that and then I will explain. Int num4 equal to 1297. I'm storing the numbers in the array, and then I'm couting sum equal to, and then I'm calling add up to find the sum. When I call the function add up, I'm passing the name of the array num and the number 4, which is the size of the array. I have to pass that size, and you will see why. Then the function add up receives. It receives the name num into the array name array, ARR. ARR is the name of another array. It's declared as the name of an array, but it's not creating another array. It's actually going to become another name for the num itself. And then size will be receiving the 4. Only if I receive the size, then I can control the loop in here and say for while I less than or equal to size minus 1. My I has to go from 0 to 1 less than size. And I can do that only if I know the size. So that's why the size is received. For I going from 0 to less than or equal to size minus 1, sum equal to sum plus array I, that will be adding up all of the elements of the array and incrementing the I. And so when this loop ends, the sum has the sum of all the elements. So let me explain how this works and why we need to send the size separately. The way it works is when you declare an array called num4 and store the numbers, then in the memory, the num4 is represented by 3 consecutive memory cells. And the memory cells in the computer have addresses. There are some numbers to identify each memory cell. These addresses are there. We normally don't use, and you don't need to use in this course. You will be learning more about these addresses and how to work with them in the next course. The computer science majors in 272, you'll be learning that. These addresses are there, and we don't normally work with the addresses, but in this case, we need to use that to understand this. The very first memory cell of the array has this address. I made up that number. We don't care what that actual address is. So that address is exactly what you're passing. In other words, the name of the array num has that address. So when you declare the array num4, this value is num1, num0. This is num1. This is num2. This is num3. Just the name num itself has the address of the beginning of the array. So when you send the num over to ARR, the ARR is getting the copy of this address. That's all it's getting. So when you refer to array 0 here, the array 0 is exactly the number at the address 3458. That's how the function is carried out by the compiler. Compiler receives, the ARR receives the address, and then ARR 0 is that address. So it goes to that memory address and gets the number. ARR 1, when I is 1, 1 is added to the address to get the next address. And that's how it goes to the next cell. And when I is 2, 2 is added to the original address stored in ARR to get to the next address. So it uses those addresses to find those numbers. And only the address is received here. So that's why when you receive an array, you're not receiving the end of the array. You're only receiving the beginning of the array. So therefore, the size of the array, how many elements are there, has to be sent over to the function so that the function can go up to that size, 1 less than size. I goes up to 1 less than size. For all those size, you're adding the array. Okay, so that's all you need to know right now is when you call the function, you only pass the name of the function and the size, name of the array and the size of the array. At the receiving end, you need a name to receive the name of the array, which has to have a bracket behind it. And then you need a variable to receive the size. And then in the function, you can do everything using that information. You can do whatever you want. Question, if I do array 0 equal to 15 here in the function, am I changing the value 12 here to 15 or not? Anybody? This says store 15 in array 0, ARR 0. The ARR is another name for the array num, isn't it? So when you change array 0, you are changing num 0. So you are changing the 12 here to 15. So the function has access to the original array. So it is being allowed to change the value of the original array. And so if you don't want that, you have to make sure the function doesn't modify the array. That's your responsibility. Okay, one example, write a function oddCount that receives an array of int type and counts the odd numbers found in the array. And it will return the count of the odd numbers. Okay, and then it says write a main program that'll use these numbers and then call the function oddCount to find how many odd numbers are there in this list. All right, so here's the oddCount function. OddCount function receives the array in the name array and then size in the name size. And then for I going from 0 to size -1, I plus plus, each element is getting this done, which means each element modulus 2. If that is not 0, that means it's odd. So each element is checked for odd, and if it is odd, counter goes up. If it is not odd, counter doesn't go up. And I'm doing that in the loop for I going from 0 to size -1. So that'll take care of checking all of the elements in the array and counting all of the odd numbers. When that loop finishes, I return the count. In the main program, B16 is getting all these data stored. And when I call the function oddCount, I pass the name B and the size 16. That's all I need to pass, name and the size. The name will be copied into array, which actually you're copying the address of the beginning of B into the name array, and copying 16 into size. And then for all the elements in the array, you're checking each one to see if it is odd, and the odd count increases. Okay, so that'll count all the odd numbers in this array, and it'll return the count. This will bring back the answer, and that answer is copied into odd, and then you're printing that number, and that'll be your count. All right, so that finishes. We don't have the time to do this warm-up exercise, but the section 6.3 is finished. So you need to do the homework on, oh, I'm sorry, 6.3 is not finished, but we are finished with the passing array. The next thing we need to learn is using part of an array that we will do in the next class. All right, that's all for today. And so you enjoy the rest of the day. I will see you Monday. Have a nice weekend, everybody.
Thank you, you too.
Thank you, Professor. Question, Professor. I know that like my internet access was a little off, so I came in and out of the class maybe a couple of times. I just wanted to make sure I was marked on time.
Okay.
I was here at the beginning of the class.
All right. If you were there at the
Just letting
beginning,
you know.
then you're marked in on time. No problem. Okay.
All right, thank you.
Yeah, the original, I took the screenshot, and if every student in that screenshot will be marked in on time. I know the internet sometimes goes off, and I don't account for that. Any other question?
Professor, I just have one doubt. So like in that size -1,
for example, in the last example, can we just write less than or equal to 15? I mean, like the number one. I mean, could you go to the previous example? I could.
This one.
My net is slow, so it just.
This is the function add up. Function add up receives the array in the name ARR and the size in this variable. And then I'm going, I starts at 0 and goes less than or equal to size minus 1. Now you can write instead I less than size.
Oh, yeah, we can write it as 5 also, right? Or less than 5.
No. When you write a function, you write the function that'll work for any size array. Okay, you don't write,
Oh,
you don't use 5. That's main program has 4 numbers. So it's sending the size 4 here, and
uh-huh.
that 4 is received in the variable size. But when you write the function, you write the function that uses the size as the size of the array. It shouldn't work for only size 4.
Professor, not for this one. The other one where like the last example where we did the we finished. We went over through the size minus
Okay.
1.
This one, odd count.
My my this thing is still loading, so I just can't say right now. Oh, I can say right now. Uh, yeah, this one.
Okay. Um,
So in this, can we write like in the main function, I is less than or equal to 70? No, I is less than 17.
um, in the
S-
main program,
In the yeah in the int. Oh, I mean in the function.
in
I
program
mean.
you can, but you don't need to write anything like that. In the main program, we are only storing the values in the array and then calling odd count, and whatever odd count returns is being printed. So there's no need for any loop or anything here in the main program, right?
Yeah. Oh, I mean, like you see the int function inside the int function, can we write I is less than or less than 16
Yeah.
instead
Let's
of
say
writing size?
Yeah, let's say I want to print all the numbers in the array. Okay, if I want to
Uh-huh.
print all the numbers in the array, then I can say for um, I has to be declared, but I assume I has been declared. I going from 0 to I less than 16. Okay,
Uh-huh.
semicolon I plus plus. Because we know the size of the array is 16, so we
Yeah.
write that, and then say I'm adding up, or I'm just printing the array. Then I say um, cout bi. That means when I is 0, bi is b0. That's the first element of the array. When I is 1, I'm printing b1. And so I'm printing the entire array in this loop by using this loop. And
Mhm.
so saying I less than 16 is okay here, because for this main program, the size of the array is 16. So I can use that, no problem.